coefficient test. Let's see, what does it go to? 44? Okay, 42, 43, and 44 were long division. And Adina, you said you were getting better with that.
Yeah.
Okay, so I'm going to start with 40. It's 41. The answer should be in the back. This is page 370, number 40. If you got it, you're helping me. If you don't, you're paying very, very extra close attention. Graph each polynomial function.
Does someone have a ruler?
No. All right. F of x equals, let's see, this is 2x squared, x minus 1 cubed, x plus 2. Okay? First thing, that's kind of the point of this lesson, is what are the zeros, also known as the x-intercepts. When you have multiple factors, you can set each one equal to 0, and what will you get, Drew?
1.
1?
Negative 2.
Negative 2?
And
0.
0.
Sorry.
Yes.
I just have to
Okay. Adina, you reply?
No, I said 0 and I'm sorry.
Oh, good. No, that's okay. Good. I'm glad you said it. 'Cause that's okay. Now, multiplicity is the thing we talked about how many times a 0 occurs. It's the same as the exponent on each factor. Exponent over here is understood to be 1. Okay? Drew, how many times does 1 occur as a solution?
He's really just...
Drew just disappeared. Martina, how many times does 1 occur as a solution?
Negative
3. This many, Martina says. Hang on, you asked about this. So this has a multiplicity of 3. How many times does negative 2 occur as a solution?
1.
1. And he's back. How many times does 0 occur?
Oh my God.
2. Okay, multiplicity of 2. ETOC. What does that mean?
Odds cross.
Okay, if you have an even multiplicity, the function touches the x-axis but does not cross it. If you have an odd multiplicity, it crosses it. So, okay? Mr. Singer came up with OCET, Orange County extraterrestrial, or Ocean City extraterrestrial, whichever you prefer. So these are the x-intercepts. These are how it behaves. If I, let's see, what is f of 0? What will f of 0 tell me?
It'll give you the
y-intercept.
The y-intercept,
which is 0.
which is 0, because what is 2 times 0 squared times 0 minus 1 cubed times 0 plus 2 to the first? 0.
Yeah.
It's 0 because of that 0 squared there. So this thing passes through the origin.
Woohoo!
Okay, end behavior, and then this is as far as I want you guys to graph it. I'm not worried about minimums or maximums, where it turns around up and down at this point. Hey, so end behavior is the next thing. If I were to distribute all this, and that would be a lot to ask of you guys. If I were to distribute all this would be squared, that's something cubed, that's something to the first. What would my first term be?
2.
What are we talking about?
The first coefficient would be 2. Hang on, guys, don't be distracting while we're recording. Okay, the first coefficient would be 2. 2x to the blank.
This?
Now, if I multiplied it all out, I'd have an x squared. That would eventually get multiplied times an x cubed. That would eventually get multiplied times an x. And Stephen is suggesting 2x to the 6th. Now, there would be, if I multiply this times itself 3 times, I know the first term is going to be x cubed.
Yeah, but why does that make it 6?
Because then that x cubed will wind up getting multiplied eventually by this x,
Which is 1.
and will eventually get multiplied by this x squared.
Which is 2.
So if I distribute a string of these factors all out, if I distribute it and multiply it, the first term will, in this case, be 2x squared times x cubed times x, which is 2x to the 6th. So you can add up the multiplicities
I was saying like 5 minutes.
and multiply the first terms of each. Okay? Does that make sense, Adina?
A little bit, yeah.
Okay.
Sorry, just one time it's funny. I can't listen to 2
I know.
happening at once.
Okay, Drew, you had a question. Okay, if I were to distribute this out,
Oh, okay, all right, yeah.
I'm not going to.
Not yet.
Alright,
I just didn't know how you got this.
Yep, 2x squared times x cubed times x. Okay, so if it starts with 2x cubed, then you add the end behavior. I call the end behavior, your book refers to it as the leading coefficient test. I just say find in the end behavior. If it starts with a positive number and an even exponent, what is this end behavior like?
Going out.
Going up both sides. I'm getting a sort of jazz hand glee sort of thing from Lauren over
Okay,
here.
really right, but like, because it's like this, because it's like more than one thing.
Right. I call that a touchdown.
But it's like,
Sort of like the YMCA thing.
Sort of like the YMCA thing, yes. Touchdown, marionette, ballerina, reverse ballerina.
YMCA.
Yeah, you could make it a dance about this. If I ask you to express the end notation, the end behavior, in correct mathematical notation, you would say that the limit, as x goes as far to the left as possible, of the function, is that the function goes up as far as you can imagine, and the limit, as x goes as far to the right as
I
possible,
always forget that and how to write that notation.
is also that it goes up. Where is x, as x is heading to the left, where is y headed? As x is headed to the right, where is y headed? That's how that math verb works.
Wait, did you have... Oh, never mind.
Negative infinity and positive
What if
infinity.
it were,
Heading to...
what if it were, odd exponent? Would it be
If it were an odd exponent, it would be either a ballerina
Oh, okay.
or reverse ballerina.
Alright.
All right. Now, if Stephen follows me over to board number 2,
Hmm.
Oh, we're recording again.
yes.
oh.
We've been recording the whole time.
Okay.
Well, I just got here.
So,
Whoa.
okay. Okay. I think I should argue about it into the microphone some more. Okay. Now, this is enough information to do a rough sketch, and that's all I want at this point. Okay? There are ways to use your calculator to help you out, and in AP Calculus, you will be asked to do this with more detail. But for now, here's what we're going to do. Okay, the zeros are x equals 1, x equals 0, x equals negative 2. The end behavior starts occurring after the 0 on the far left and the 0 on the far right. Since it's touchdown end behavior, I can go ahead and put that in and know that life is good. The multiplicity tells me that it crosses at 1 and 3 and touches at 2 without crossing,
Whoa, wait.
so it must do something like that.
Pause.
Yes.
It touches at 1 and 3, and...
I'm sorry, I said that exactly backwards, didn't I?
Yeah.
Yeah, it crosses at 1 and 3. Thank you, Lauren.
Oh,
And
horrible.
so that
Wait,
only
wait,
turns
it
around and
crosses
touches.
at 1 and 3?
Yes,
Oh, multiplicity-wise.
yes.
Wait.
Odd multiplicity tells me that it crosses the
Okay.
x-axis.
No, I
I'm sorry,
thought-
at 1 and negative 2,
Yeah.
I was reading the multiplicity of 3.
That's what
Yeah.
confused me.
And it touches at 2. Questions on this
You mean
one?
0.
Wait, why?
Good Lord, thank you. Yes, I do. Yes.
So why do they both go up when one going down?
Touchdown.
Nope, it's an even exponent. So that makes it a touchdown shape for end behavior. Odd exponents are one of the ballerina shapes.
It's a plus negative.
Okay, so you don't like go based on like the highest number exponent.
Well, you do, but only after you multiply it all together.
Okay.
Whatever the degree of the polynomial would be, which you wouldn't know unless you distribute it, but I'll go ahead and tell you that it's going to be 2x squared times x cubed times x.
Okay.
So that will be my first term.
I do.
Yes.
Oh, no, never mind.
Okay. Now, what I'm not asking you to figure out now, but James and Brandon did a little bit last year with their calculators, is where these points are. Don't care about that right now. This is just a rough sketch. Okay?
It asks-
I'm not asking about how low it goes, where the minimum or maximum go, and I don't believe it asks for that. Please tell me it doesn't.
No, it asks for the symmetryness.
Right, ignore the symmetryness. I meant to say ignore that, and I forgot to leave those instructions for this. Forgot to leave that in the instructions for the substitute. So this is the quality of graph I want. I'll be very picky about the end behavior and the intercepts and whether or not it turns around or crosses at the intercept, but that's about it for now. Does that make sense?